Hi there, this is Professor Eckhouse, and I am going to talk today about section 4.2 in intermediate algebra. We're going to talk about graphs of functions, 3 different kinds of graphs. But first, please try this warm-up, see how you can do with it. Just pause the video, give it a try. Okay, so hopefully you gave this a try, and I want you to remember that when we take something and square it, it just means that we're multiplying them together twice. Right, whatever the number is, we're multiplying it twice. So exponents just represent repeated multiplication. All right, so the first one, -1 squared, we've got -1 times 1. And this is the one that always throws people, and the one I see people get wrong all the time, and it messes up answers to big problems. Because the 2 is only applied to the 1. The squared is applied to the 1, not to the negative. For instance, if I had something like 5x minus 3y plus 2 squared, what would the squared apply to? Would it apply to the plus? Would it apply to the y? Would it apply to the where does it stop? Well, it stops at the number, unless there's a parenthesis. So when there's a parenthesis, like the next one, we would get -1 times -1. Notice the difference here in that the first one is going to be -1 times 1, -1. The second one is going to be -1 times -1, +1. And thus where the problem lies for many people. So make sure you've got that down. The next one is -1 in parentheses. I guess I'll just keep it in parentheses. It doesn't really need to be, but just so it looks the same. And then again is -1. And I want you to just pause the video for a moment and notice the difference and similarities between those two. All right, let's move on. So we are going to talk about graphing linear equations, quadratic equations, and radical functions. So linear functions, quadratic functions, radical functions, what do they look like? They all look very different. We're going to look at transformations of these when we work in class together, and we're going to identify some important features like the vertex. So I'm going to start with linear functions. It is the simplest. There are 2 different forms we're going to look at, and that is this form, which is called slope-intercept form. Slope-intercept form. That is this one right here. Why is it called slope-intercept form? And that is because this is the slope and this is the intercept. And I am having some serious technological difficulties with my iPad right now, so we'll see how this goes. This one is called standard form. And I want you to notice that how different it looks. Y is alone in slope-intercept form. And in the standard form, the constant term is alone. So this is the constant term. All right. So let's look at these. We're going to look at what each of these looks like. At this point, I think you probably know what a line looks like, so let's just plug these in. We've got -1, 0, 1, 2, and 3, plugging into 2x minus 4. So I'm using this equation, and I'm going to graph it. So I'm finding the y value by plugging in each of those numbers for x. And I'm going to get -6 for the first one. The next one I'm going to get -4. Then I've got 2 minus 4 is -2. Then I've got 4 minus 4 is 0, and 6 minus 4 is 2. So now each of these gives us a coordinate pair. And so we've got -1, -6, 0, -4, 1, -2, 2, 0, and 3, 2. All right, so we're going to plot each of these, and we get -1, -6, 0, -4, 1, -2, 2, 0, and 3, 2. Okay, so we can draw a line through this because this is an equation, and it is the equation of a line. Okay, so that's a linear function. Okay, so that was just a little warm-up. Quadratic functions. I'd like you to try to do the same thing with this. Pause the video and plug in each of these values into this equation. Okay, so this is a quadratic function, and we are going to look at what a quadratic looks like. So give it a try. All right, so you're going to, y is x squared. So we're going to take negative 2 squared. Notice I'm going to use parentheses each time. Don't forget to do that every single time. I don't know why I can't talk at the same time, I guess, today. So we've got a negative 2 getting plugged in, a negative 1, a 0, a 1, and a 2. All right, so now the reason we use the parentheses is because we need to square the whole thing, the negative as well. It's a number negative 2, and the whole thing needs to be squared, and it becomes 4. All right, then square negative 1, and we get 1. Square 0, we get 0. Square 1, 1. Look at the symmetry in this. There's definitely some symmetry going on. So we get negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. Noticing the symmetry, hopefully. And we get negative 2, let me do this in a color, negative 2, 4, negative 1, 1, 0, 0, 1, 1, and it goes on symmetrical like that. If you plugged 3 in, you would get 9. If you plug negative 3 in, you would get 9. So a quadratic, the shape of a quadratic is a parabola, okay? A parabola. That's what that is called. And there's a point right here at the bottom, and that is called the vertex. There is a line down the middle. It's going to be hard to draw here because it's right on the y-axis, and that is called the line of symmetry. Okay, it's symmetrical about that line. So if this point is 3 away from the line of symmetry, so is that one, and so on. All right, so the general form of a quadratic looks like this: y equals ax squared plus bx plus c, where a, b, and c are all the coefficients, or the constant are numbers, or they could be a 1. They could be a 0, and if they were a 0, that term would go away. Of course, a can't be 0, or else it won't be a quadratic anymore. So we're going to use Desmos to investigate how these affect the shape of the graph, but we're going to do that in class together. All right, so let's look at how to find the vertex with the following formulas. So the vertex is HK. That's what we call this vertex right here. We call it HK, which of course is just XY. It's an XY point. We give it special letters because it represents a special point. The formula for the vertex is going to be this right here. So make sure you have this in your notes, nice and big box around it, along with this. These go together. Okay, so this B right here is this B right here. This A is this A. I'm going to erase those, but I wanted you to see them. And so on. All right, so H is going to be B over 2A, and we take the negative of that. Then K is going to be f of H. So whatever you get for H, you plug it in and plug it into the equation, okay, which we can then just call f of negative b over 2a. All right, so the vertex for this particular equation, so let's write down this particular equation. Oh, I'm sorry, that's not what I wanted to do. We'll do that in just a moment. So the vertex is at the point HK, which is at the point negative b over 2a, and then f of negative b over 2a. Okay, so that is where the vertex is. You can write that down, put that with the rest of it. Okay, and we will practice that. So looking at the homework that you might see would look like this. How would you find this? Well, you first have to take this equation right here and decide what A, B, and C are. So that's the first step. A is what? Well, it's this negative 2 right here. B is what? It's going to be the negative 4, because the standard form of the equation has pluses. So if it's a minus, it's going to be a negative 4. And then C is the 1. It's the constant term. Okay? All right, so now we need to find the vertex. So we need to find HK. The vertex, remember, is HK. Well, first we have to find H, right? So H is going to be negative B over 2A. Well, we found B. B is negative 4. So don't forget the negative is out front, and then we have another negative 4 there. And then over 2A, so 2 times what is A? A is negative 2. All right, so we've got negative of -4, well, that's +4, over -4. And so we get -1. H is -1, all right? So there's our vertex, half of our vertex. -1, what? Well, the way we find y is always just to plug in x. So don't make this more complicated than it needs to be. I know this formula up here looks complicated, but if you just find h and then plug it in to find k, it's the other half of the coordinate pair. All right, so let's plug that in. I'll use a different color so you can see we're doing something different. We're going to say k is going to just be f of -1. Well, here's our f right here. So we're going to say here, I'll write it down here, -2 times -1 squared minus 4 times -1 plus 1. Okay, let me clean this up a little bit so you can see what I did. So make sure you understand that this -1 that I plugged in, right, is this -1, h. I just plugged in h. All right, so I've got -2 times -1 squared is 1. -4 times -1 is +4 plus 1. All right, so I've got -2 plus 4 plus 1. -2 plus 4 is 2, plus 1 is 3. All right, so now we have this point. It is 3 as the k value. So I'm going to come up here, and that's my vertex. So -1, 3 is here. All right, double checking that I did this correct, because I did not write down a key for this. I'm just doing it as I go, so I want to make sure I've got it right. All right, so the vertex is -1, 3. -1, 3. All right, so now how do you graph this if you're using our online homework manager? Well, they say right here that you need 2 points. That's what the 2 red dots are. You got to choose the tool and then just 2 points, the vertex and 1 other point. So let's find 1 other point. What point is the easiest to find? What do you think? How about f of 0? 0 is easy. I've got -2 times 0 squared minus 4 times 0 plus 1. You could even do that in your head if you realize that that is going to go away and that's going to go away. And what are you left with? You're left with 1. So that means our point is 0, 1. All right, so 0, 1 is right there. All right, so now since this thing is symmetrical and the line of symmetry always goes through the vertex, we know that there's going to be another point right there too. And you could try it. You could put -2 in. But for the online manager, all you need is 2 points. So it looks like that. You could pick more points if you want. Now that you know which way it faces and kind of what it's doing, you could pick a couple more points if you would like. All right, so that is a quadratic function. All right, so now let's move on to radical functions. This is the opposite of squared. This is square root. So this is the inverse, right? Y equals the square root of x is a radical. So we could take the cube root or the fourth root, but we're just going to look at square roots. So plugging in these numbers over here on the left, the x values, we've got x is 1 or 2 or 4 or 9 or 16. Why did I pick those numbers? Because they're perfect squares and we can do it in our head. So y is going to be the square root of 1, which is 1. It's going to be the square root of 2, which is actually 1.4-ish. Square root of 4 is 2. Square root of 9 is 3. And the square root of 16 is 4. Now there's also some negatives too, but that would make it not a function. So we'll get into that later. But we're only going to use the positive answers to the square roots. So let's plot this. And oh, I should have put in 0 because that's where it starts. The square root of 0 is 0. So our point there is 0, 0. So 0, 0. I'm going to do this in orange so we can see it. 0, 0. The next point is 1, 1. So if you want to put these as points, you can. 2 and 1.4 and so on. Or you can just use it straight from the table, which is I'm going to do for the rest of the points. So there's 1, 1. 2 and 1.4 is probably about right there. And then 4 is 2. And then 9 is 3. Notice how slowly this thing is growing. And then 16 way out here, right, would be 4. So this thing grows really slowly and looks like that. That's what a radical looks like. Okay. that wasn't a very good picture, but hopefully you get the idea. All right, so those are our three functions that you need to know what they look like. A radical function looks like this. A quadratic function looks like this, and sometimes it is going to be flipped over, and we'll talk about that. And a linear function is just, of course, a line of some sort. All right, thank you for watching.